So with chapter 9, we're jumping back into what would be considered traditionally as general chemistry, as opposed to the organic or the biochem. And we're going to start by just kind of operationally defining some terms. So when we talk about solutions, there are some terms that we're going to use to describe those solutions and the components of those solutions. And if we can kind of get that terminology out of the way, it's going to make things easier for us when we go to actually start to look at some of the other things that we're going to do. So solute. When we say solute, what we are talking about is two things. Solutes are the component of the solution or components in lesser amounts. So if I make a solution with 300 grams of water and 2 grams of sugar, the 2 grams is the lesser amount. That would make the sugar a solute. We have a different word for what the water would be. Solutes are also the stuff that gets dissolved. So again, if I'm making a solution of some kind and I'm pouring a small amount of one thing into a large amount of another thing, that small amount is going to get dissolved in the larger. That small thing, that's called a solute. It's possible to have multiple solutes in the same solution. So, and you can even think about this. If I pour sugar and salt into the same cup of water, they're both going to dissolve. But I want to drink the resulting solution? Well, it depends on the context. Am I just pouring it in randomly? Or is this in prescribed amounts like what a Gatorade? That's basically what Gatorade is. Flavoring, sugar, salt, water, and a bunch of other stuff that is hard to pronounce. These solutes will spread out evenly in the solution. These solutes will mix with the solvents to create a uniform kind of state. Usually that state is a liquid, but it doesn't always have to be so. And because they have been integrated together in this uniform kind of way, we can't use filtration to get them apart from each other. At least not easily. The other thing that we should know is that these solutes, they can be in any phase. They can be in solid phase, they can be in liquid phase, they can be in gas phase. Now, when they dissolve, they usually take on the phase of whatever the solvent is, whatever the stuff that did the dissolving is. So you might start off with solid sugar, but by the time you mix it into the water, it's going to appear to be liquid. That's because it's taken on the phase of the water. Now, the action that takes place is kind of cool. So when we start, so this is an example, we've got 2 graduated cylinders here. One, we started with a solid copper sulfate here at the bottom. That's what this dark blue stuff is. And on top of it, we just poured a bunch of water. If left to its own devices, we don't have to shake it, we don't have to stir it. If we just let it sit there long enough, what will happen is that the water molecules inside of here will start to separate the copper and the sulfate ions from each other and distribute them throughout the liquid. And this happens completely on its own. Doesn't require anything from us, but obviously if we shook it up or if we stirred it, it would happen faster. Solvents, on the other hand, solvents again, those are the components of the solution that are present in the greatest amount. They're the stuff that does the dissolving as opposed to being dissolved. And this slide here I like a lot because it really shows the variety of different kinds of solutions that are possible. Again, solution itself just indicates that we have a mixture that is homogeneous, uniform. Can't tell one component from another. It goes way back to kind of our early definitions, chapters 1 and 3 at the very, very beginning of all. And we see there's lots of examples. Gaseous solutions, you think of things like air, where we've got a mixture of a bunch of different gases, and I can't tell any of them apart from each other. Liquid solutions are generally what we think of, and we can think of them in a number of different kinds of contexts. So gas phase solutes, like carbon dioxide and water, that's soda water. Liquid on liquid, here's your vinegar solution, acetic acid mixed with water. Solid and liquid, again, we talk about a number of those. Sugar and water, salt and water. They use some other examples here. Solid solutions, it's possible to have solids and solids. Call those outlets. Brass, common mixture of zinc and copper. Steel, common mixture of carbon and iron. Then you throw in other kinds of descriptors like stainless steel or galvanized steel, where we throw in some zinc in the mix. These are all solutions because they are mixtures of solids that are uniform in nature. I can't pick up a piece of brass and go, okay, there's the copper part right there. It doesn't look like that. It's uniform. It comes when we melt those two elements together in a particular ratio. So where we're going, obviously we're going to talk a lot more about solutions kind of from a broad perspective as well as a fine perspective. But the majority of the solutions that we're going to focus on are these kinds of solutions. Solutions where water is the solvent, and they have a special name. These are known as aqueous solutions. Aqueous, aqua, water. These are water-based solutions. So tomorrow when we come back, this is where we will pick up. But again, I just wanted to kind of operationally define some of those terms for us so that we at least were jumping off from a common place tomorrow. Have a great afternoon.